Okay, so we are in on week 5. Okay, so which is secret key encryption. Okay, so we've already released the videos for this. It's quite an old video, so I hope you are able to appreciate the effort in preparing these old videos, but they're quite lengthy. So for today, I'm going to discuss just some of the key points that are essential para sa secret key or symmetric encryption. Okay, so status ng mga submissions nyo, buffer overflow, wala pa. Shell shock, I think, ilan ba ang shell shock? Tatlo pa lang nakasubmit ng shell shock. And for the environment variables, 9. Okay, so slowly nakakatapos din kayo. So okay na yan at your own pace. Okay, so today we're going to focus on secret key encryption. So sa computer or sa cybersecurity, very essential yung encryption. And the field of study is actually called cryptography. Okay, so this is another main area ng cybersecurity, cryptography. Now, maraming mga estudyante na nako-confuse na yung definition ng ano ba yung differences. So uunahin ko muna dito yung differences, kasi yung mga estudyante nako-confuse sila. Ano yung difference ng encoding? Ano yung ibig sabihin ng encoding? Ano yung ibig sabihin ng hashing? And ano yung ibig sabihin ng actual encryption? Okay? Kasi pag may nakita kayong parang something na incomprehensible text, iisipin niyo agad, encryption yan. Pero hindi necessarily na encryption yon. So itong first item nitong ating discussion will focus on clarifying what these terms really are. So the first is yung tinatawag na encoding. Kasi maririnig nyo lagi ito sa cybersecurity. So yung encoding, i-recall nyo yung line coding sa 137, di ba? Meron kang digital data, ko-convert mo sa digital signals, ones and zeros. May mga voltages ka. So encoding is more on transforming one data format to another. Okay? And an example of that is base 64 encoding. Okay? Bakit meron tayong, kung familiar kayo sa base 64 encoding, basically you provide any type of input. It can be a text input or it can be a binary input, and it will generate a text input. Okay? So ang purpose yan actually is for transmission. So let's say meron kang image. Di ba yung image mo ay binary file yon? Gusto mo siyang i-transmit sa text-only transmission system. So ang maganda dyan is i-convert mo siya sa isang text format using base 64 encoding, and yung base 64 ang i-encode mo and papadala mo yun sa transmission link. Okay? So text format siya. Then at the opposite end, pwede mo siyang i-decode. Okay? So an important aspect of encoding is that it is reversible. Sabihin, once may in-encode ka, pwede mo siyang ma-decode. So here's an example run that I did yesterday. So we have here the command echo. Okay? So you can use -n para ma-suppress yung new line sa file. So echo, and then this is the text, and then base 64 encode. So ito ngayon yung lalabas. Okay? So this will be the base 64 encoding of this particular text stream. Okay? And yung opposite niyan, pag ito yung pinadala mo sa transmission link, yung opposite niyan is yung decoding. So kung ito yung text, kinapi-paste ko lang yan, tapos in-echo ko uli siya, tapos pinipe ko dito sa base 64 decode, then I was able to retrieve the original text, no? So yung ibang tao, isipin nila, encryption yan. This is not encryption, but rather it is encoding. So itong text na to, ini-encode niya in a different way para maging siyang transmittable in a text format. Okay? So I hope you will remember that distinction, kung anong ibig sabihin ng encoding. I-post nyo na yung question nyo sa chat ko, meron kayong tanong. So the next one is hashing. So ito isa rin 'to na nako-confuse ng mga tao na akala nila yung hashing ay encryption. So 1 2 3 alam naman natin, you know that in 1 2 3 meron tayong hash function, di ba? So we have an input and we generate a number that serves as an index dun sa hash table natin. So yung hashing, cryptographic hash functions, basically what it does is to generate a fixed length output for a variable length input. Okay? Para saan 'yon? Okay? Basically, ang pinaka-purpose niya is to provide or to guarantee integrity. Okay? Kasi di ba, malalaman mo na corrupted yung file na dinownload mo pag merong naiba dun sa contents niya, right? So yung hashing, yun yung ginagawa nun. Okay? So meron kang file, meron kang installer, meron kang ISO, okay? Meron kang movie file na gustong panoorin, or may document ka na gusto mong i-validate yung integrity niya na hindi nagalaw yung package na yon or yung file na yon. So gagamit ka ngayon ng hashing. And this is a one-way hash function na tinatawag nito. So ibig sabihin, kung meron kang hash value, which is the output nga, which is the output, is a hash value, okay? From that hash value, hindi mo ma-recover yung actual contents nung hinash mo. Okay? Unlike to sa encoding, ito yung output ng base 64, pwede mo siyang i-decode. Dito sa hashing, yung hash value na na-compute mo from the input, hindi mo siya pwedeng ibalik, i-derive from the hash function. Okay, so that's one thing to remember. So it basically used to guarantee integrity. Example of these are MD5 SHA-256 or Secure Hash Algorithm 256. So basically, yung ano naman dyan is yung length ng output. Di ba? Fixed variable length input, tapos we have fixed length output. So in the case of MD5, so this is an example, the same input, yung input string natin, no? And then pinipe lang natin siya sa MD5 sum. And MD5 sum is computes the hash, MD5 hash, and ito yung kalalabasan niya. Okay? So this is the hash value, okay? And then pag inulit mo uli yun, the same output will be produced. Okay? So kasi yun yung parang yung algorithm niya will be unique. So ibig sabihin, pag ito yung na-receive mo na hash from the previous, ibig sabihin, they are exactly the same string. Okay? So yun yung purpose nun. So for example, kay Ma'am Bethel yung pangalan niya, pag in MD5 sum niya, ito yung lalabas. Okay? Ito naman yung lalabas sa akin. So iba-iba yan, depende sa input. Yung mga-compute niya na hash function. Pero given this hash function, hindi ko masasabi agad-agad or in an easy manner, in an efficient manner, kung Bethel ba to o Jack. Okay? So ganun yung MD5 sum, and the same with SHA-256 sum. Okay? So this is 256 bits. So mapapansin mo ngayon na mas madami siya kumpara doon sa MD5. Okay? Meron na bang nakagamit nitong MD5 sum saka SHA-256 sum sa inyo? Wala pa?
Hindi pa po, sir.
Okay, great. So, mapapansin niyo yan pag nag-download kayo ng mga ISO, ng mga installer, okay? Para ma-check niyo kung na-corrupt ba yung download niyo o hindi. So, that's a very important. Mapapansin sa Ubuntu, no? Sa katabi na meron nakalagay na SHA-256 sum na pwede niyo i-download. Na i-compare niyo lang kung pareho yung na-compute niyo na na value dun sa na-download niyo. Okay? So verifies the integrity. So yan yung hashing. And oftentimes nako-confuse naman yung mga estudyante kasi akala nila encrypted siya. Okay? So the last one is yung encryption na itself. So yung encryption itself is the idea is to encode an input, which we call the plain text, to an output, which we call the ciphertext, using a key. Okay? So ito yung parang pinaka-concept. Pero you will notice na merong word na encode dito. Okay? So yung encode ba, pareho ba siya nung encode na nandito? Okay? More or less the same yung process. Okay? Pero, meron ba dito? ito, the reverse process is called decryption. So recitation, what difference between encoding and encryption can you see? Okay, based sa description na to, ano yung makikita mong magkaiba sa encoding saka encryption? Meron ba kayong ano? Anyone can just type in your answer. Ano pinagkaiba ng based sa description pa lang? So, sa example runs natin. Sa description pa lang, ano yung mahirap yung pinagkaiba? Okay? Sirit na ba? Okay? Ito. Yon, merong may key po yung encryption, correct? Okay? So sa encryption meron kang key. Okay? Unlike sa encoding, base 64 encoding, wala kang key na makikita diyan. Just the algorithm itself. Okay? So that's good. Good, Rafael. Okay? So yon. May key lang yung sa encryption. Okay? So what's the purpose of this encryption? Kung yung hashing ang ginagaranti natin ay integrity, ito naman ang ginagaranti nito is yung confidentiality. Okay? So we try to scramble the original message para pag transmit natin siya sa transmission media, hindi siya ma-eavesdrop or ma-interpret ng iba na hindi naman para sa kanya yung data na yun. Okay? So you've done this in GPG. Okay? What are some examples of this? We have DES or the data encryption standard, triple DES, okay, and AES, which is advanced encryption standard, and we have a very basic rotate 13, which is a CSAR cipher. Okay, so here's an example, which actually what you're going to do in the lab, in this lab. Okay, so we have this text. Okay, sinave natin siya sa isang text file, plain.txt. Okay, and then check lang natin kung na-create ba yung file na yon. And then we use OpenSSL, and then the command, the mode encryption, and then we use this cipher. Okay, we call this the type of cipher. We'll discuss this later, but this is AES, Advanced Encryption Standard, 1 to 8 bits, and then this is the black cipher mode. Okay, and then we use the -E to encrypt, and then our input will be the text file, which is this one, and then the output will be the this file, which is a binary file, basically. So that's why I call this a cipher.bin. And then we have the key. Okay, so sa AES, ang key natin dito ay, which we will discuss later, is 128 bits. So mapansin nyo na ito ay parang key na, ito yung key na gagamitin natin sa encryption. Okay, and after running this command, we're going to have an output cipher bin, and pag kinat natin siya, ito yung lalabas. Okay, so it's binary, kaya nga nilagay ko dyan na bin. And then it's better to use hex viewer, XXD, para makita natin yung contents ng file na yon in hex. Okay, so yan yung kinalabasan niya. Okay, and then this is the encryption process. So we have this encrypted. This is called the ciphertext. And then the opposite step, which is the decryption step, ganun din. OpenSSL, encrypt, and then ito yung mode. And this time, -D for decrypt. Tapos ang input natin, yung ciphertext, and yung output natin ay yung decrypted text. And take note that it should have the same key. You can experiment in the lab, subukan nyo magkaiba yung key na gamitin to decrypt. Iba yung key na ginamit nyo sa encryption, tapos iba yung key na ginamit nyo sa decryption. Tingnan nyo kung madi-decrypt niya yung actual message, yung original message. Okay? And in this example, since pareho yung key na ginamit natin, so we get the decrypted text, which is the same as the original plain text. So that is basically encryption. Okay? So sa natin, sa 137, niyan, tinuro yan dun sa GPG. Okay? So yun, other questions? None? Okay. So we now focus on the actual idea about encryption, no? So basically, meron tayong plain text input, tapos meron tayong encryption algorithm. It can be the different algorithms, DES, triple DES, or AES, which is commonly used. So, ang ginagawa niyan, transpositions. Okay? So, parang may pinapalitan ka na character, tapos nilipat-lipat mo, shifting na tinatawag. So, yun yung pinaka-internals ng algorithm. And you have an input key, and lalabas siya yung tinatawag na ciphertext. So, you can actually think encryption as a function E with two parameters, two inputs, the key and the plain text, and it will generate ciphertext, and it will be transmitted on the transmission medium. And then at the opposite end, it's important that the same key is used. That's why it's called symmetric. And then using the reverse of the algorithm, you have the decrypt function, the key and the ciphertext, you will be able to get the X, which is what we demonstrated in this basic run of the OpenSSL command. Okay? So, yun. So, the next question is, okay, thank you. Dahil meron tayong encryption. Okay? Solid na. Okay, yung confidentiality natin. But, is there a way to break the encryption? Okay? So, there are two approaches to do that. The first one is called cryptanalysis. Okay, wherein you need to have some idea of the algorithm, how the algorithm works, and also some knowledge about the characteristics of the plain text, the key, and the ciphertext. Okay, so kung bibigyan ka ng isang encrypted text, gusto mong makuha yung, let's say may ciphertext ka, gusto mong makuha yung plain text. Okay, you need to know the algorithm and some properties of the plain text and the ciphertext in order to be able to get the plain text. Okay, so that's cryptanalysis. We'll discuss this later. Actually, this is what you're going to do in the lab. Okay, then another approach is yung brute force attack. Okay, so remember na meron tayo dito sa example natin, meron tayong key na ginagamit. Yung brute force attack, itatry mo lang yung all possible keys na pwede para makuha mo yung plain text. Okay, given na alam mo yung decryption process. So itatry mo lang yung all possible keys. However, syempre, the longer the keys, the harder or the larger is the search space. Okay? Yung madami kang itatry. Kung 2 bits lang yan, madali lang. 4 ano lang yan, 4 combinations, di ba? Kung 3 bits, 8 combinations. So as you increase the key size, lalaki yung iyong key space or yung search space. So that will not be effective. But dahil sa advancement ng hardware ngayon, especially for the creation of the GPUs, for example, you can actually perform brute force attack faster. So halimbawa, yung DES, yung data encryption standard, which is an old encryption standard, is actually broken now. Kasi kaya 56 bits lang yung kanyang key. So kayang-kaya siyang i-decrypt using brute force attack. Okay, so yan. So take note of these two steps, of these two approaches to breaking cryptography. Okay, the next topic is all about block ciphers. Okay, so yung block ciphers, ito may aside ako dito. It's best at this point to think in terms of bits and bytes. Okay, instead of characters and letters. So sa cryptography, iset nyo na yung isip nyo na you are manipulating bytes or bits instead of letters, numbers, etc., symbols. Okay? Basta ang minimum unit of information na mina-manipulate are bits and bytes. Okay? So take note of that. So ano yung block cipher? Yung block cipher, the idea here is if you have a large chunk of information of data or file, for example, yung encryption algorithm, kaya siya tinatawag na block ciphers kasi i-chop niya yon into small chunks, fixed size blocks, and then doon niya i-perform yung algorithm, okay? Yung encryption algorithm. So what happens is the plain text is broken into fixed size blocks. Usually the units, the unit is bits. Okay, so for example, for the advanced encryption standard, 128 bits yung size nung block. Okay, and the processing is done per block to produce the ciphertext. So yung kung ano yung block size nung pag-chop niya, yun din yung produce niya na ciphertext, block size ng ciphertext. For example, sa AES, 128 bits din yung kanyang block ng ciphertext from the 128 bits na plain text. Okay? And also, the key has a given size. So for example, yung AES, pwede siyang 128, 192, or 256, yung key size. So these are all in bits. So kanina, sa example ko kanina, ito makikita nyo dito, na AES 128 ECB. So AES, alam nyo na, and yung 128, this is actually the key size. Ibig sabihin, 128 bits yung key size natin. Although, yung AES, pwede siyang magkaroon ng 192 or 256 bits na key size. Okay? So, here I have another aside. So, kung 128 bits yung block size ng AES, ano ibig sabihin yan? That is 16 bytes. Okay? So, and 2 hex digits is actually equal to 1 byte or 8 bits, and 1 hex digit is equal to 4 bits. So, take note of this conversion. So, mapapansin nyo dito sa example na to, yung key na pinasa natin dito, ano yan, 0011. So, mapapansin nyo na 16, ano yan, 16 bytes yan. Ito. 16 bytes lahat yan kasi bawat symbol dito isang hex digit which is 4 bits. So, in total, yung key size nito ay 128 bits kaya ganun siya kahaba. Okay? So, yan. Kasi gagawin nyo yan sa lab later. No? Try nyo yung supply ng mga to. So, it's actually variable. Bahala kayong mag-set niyan as long as 128 bits siya. Pwede nyo i-reorder to or whatever. Ibang set, basta make sure na 128 bits yung size ng key. Depende dun sa cipher na ginagamit nyo. Okay? Malinaw ba yan? So, those are block ciphers. Sinachop mo yung large chunk and then the encryption happens per block. Another one is yung tinatawag na stream cipher. So, yung stream cipher, the plain text is processed continuously. Okay? So, usually sa mga network systems, ito kasi yung data mo nagfo-flow continuously, stream-based. No? So, the plain text is processed continuously. It can be 1 bit or 1 byte at a time. And it's faster and used in communication networks. An example of this will be RC4. Okay? So yan, yan yung dalawang klase ng ng ciphers. Okay, block cipher saka stream cipher. Okay? Typically in normal use, block cipher yung ginagamit. Okay, so I have a recitation question here. Should we implement our own encryption algorithm? Yes, what are your thoughts about this? Ask ko si Kirby, sa tingin mo, should we implement our own encryption algorithm?
Hello po, sir. Rinig po ba?
Yes, I can hear you.
Siguro po for me, better po siguro na mag-create. Siguro pa di ko pa po masyadong napaprocess yung mismong ano. Pero parang po, kumbaga, kasi sa encryption, much better kung mas personal, ganyan. Kasi ikaw lang yung nakakaalam on how to crack it, ganyan, or how to deal with it, na mahihirapan yung ibang tao na i-figure out kung paano mo din-assign yung encryption po na yun. So parang better po talaga, sir. For me po.
Okay, thank you for your inputs. Great. Okay. So yun yung common na so actually I can call it a misconception. Okay? Sometimes yung sabi kanina, sabi na mas personal. Kumbaga, konti lang yung nakakaalam, mas maganda na okay yan, yung encryption tekniko, yun na lang yung i-implement natin dito. So that's actually a misconception. Kasi kahit sabihin na natin na complicated yung yung algorithm mo, merong isang magaling somewhere there na kayang i-decrypt yung iyong unique or custom algorithm. Okay? So it's always important as ComSci students, as programmers later in the future, na do not roll your own encryption algorithm. Rather, stick to the standards and use existing well-tested libraries. Kasi maraming nagkakaproblema dyan na pag may inimbentong sarili, let's say may project siya, may web app na ginagawa, gusto niya i-secure yung data niya and nag-invento siya ng sarili niyang encryption algorithm, eventually crackable pa din yan. Okay? So that is a common misconception. Okay? So baguhin nyo yan after nung 191. Okay? Do not roll your own encryption algorithm. Gumamit kayo ng libraries. Example is yung OpenSSL. Although yung OpenSSL meron siyang bug before na pwede mong i-decrypt without keys. Okay? So yan. So tandaan nyo yan, sa 191, pag may mga projects kayo, do not implement your own encryption algorithm, use a library, tested library. Okay? So maraming mga problema dahil dyan, umimbento ng sariling libraries. Okay. So thank you for your contribution, Kirby. Next is classifying crypto systems. So how do you classify crypto systems? Okay. There are several dimensions that we've touched already. The first one is operations for transforming plain text to ciphertext. So dalawa lang yung operation niya, yung substitution saka transpositions. Okay? Doon sa lecture videos, nandun yung details kung paano, halimbawa yung Fistel cipher. Okay? Paano siya gumagana. Okay? And the implementation, the theory behind DES and AES, nasa lecture video na yan. Okay? So we can use that to classify to classify the crypto system. Another is the number of keys used. Okay? Pwedeng dalawang klase ito, pwedeng symmetric, pwedeng asymmetric. So yung symmetric, isang key lang yung ginagamit ng sender and receiver. So this is an example of a typical symmetric encryption. So you have one key both used in the encryption and the decryption. Okay? Yung isa naman, yung asymmetric, dalawang keys yan, which we will discuss next week. Yung public key saka yung private key. In fact, sa ComSci 137, yung GPG exercise nyo, sa akin, sa lab ko, ang pinagawa ko is pina-download ko yung public key, tapos mag-send sila sa akin ng encrypted message using my public key. Okay? So, yun, that's one. And the way the plain text is processed, as discussed earlier, it can either be block or stream-based, stream cipher or block cipher. Okay? Now, let's move on to crypt analysis kasi ito yung essence ng security dito eh. If you are given a ciphertext, can you get the plain text? So yun yung challenge sa cryptography. Okay? So we have different types of attacks which you will actually do in the lab. So the first one is called the ciphertext only attack, wherein you have the encryption you have a knowledge of the encryption algorithm and the ciphertext to be decoded. Dun sa lab natin, okay. So this is task 1, frequency analysis. Okay? Ang mangyayari doon sa frequency analysis, ang given ka lang dyan ay yung ciphertext tapos yung algorithm. Okay? And you can do, actually ciphertext lang eh, pero given kung paano create yung ciphertext na yun. So you can use frequency analysis which is described in the lab handout. Okay? Another one is known plain text attack. Ibig sabihin, alam ng attacker yung encryption algorithm, alam niya yung ciphertext na i-decode, and one or more plain text ciphertext pairs formed with a secret key. So meron kang available na ito yung kailangan mong, ito yung ciphertext na dapat mong i-decrypt. Pero bibigyan kita ng plain text, tapos ito yung corresponding ciphertext na na-produce from this plain text. So yun yung known plain text attack. Yung chosen plain text attack naman, alam mo yung algorithm, okay? Yung ciphertext na kailangan mong i-decode, the plain text message is chosen by the crypt analyst together with its corresponding ciphertext generated with the secret key. So ito gagawin nyo itong mamaya, actually sa lab, gagawin nyo itong dalawang to. Okay? And we have other approaches like chosen ciphertext and chosen text. Okay? So yun, sa types of attack na gagawin nyo. Okay? At least itong tatlong to. Okay? Gagawin nyo yan. Now, another important topic na kailangan alam nyo sa cryptography is yung tinatawag na modes of operation for block ciphers. Okay? So ano yung modes of operation? Ang ibig sabihin nun, di ba yung block cipher, china-chop-chop siya into fixed block sizes, no? Fixed size block. Okay? So yung encryption, yung mode of operation will determine kung paano yung algorithm, kung paano ano yung relationship ng mga blocks habang ini-encrypt siya. Okay? So mahalaga to kasi yung mode of operation will somehow dictate kung ano yung type ng attack na pwede mong gawin dun sa given ng ciphertext. Okay? So alam mo dapat yung mode of operation and given ka ng ciphertext. Okay? So meron 1, 2, 3, 4, 5, limang commonly used mode of encryption. The first one is called the ECB or the Electronic Code Book. Okay? So ito yung pinaka-basic. Okay? Ito yung ECB. This is your plain text, di ba? So hinati mo siya into 3 blocks in this example, n blocks. Okay? So hinati mo siya into n blocks and then independent sila. Okay? Independent sila. Okay? So after mo ma-split, encrypt mo na. Okay? B is the number of bits, encrypt, and then you get the ciphertext. Independently, walang relationship yung mga blocks habang ini-encrypt mo siya. Ang gagawin mo lang, i-concatenate mo na lang to para makuha mo yung final encrypted na ciphertext. Okay? Now, sa lab nyo, merong activity dito, ito gagawin nyo. Easy lang naman to, parang yung dinemonstrate ko kanina. Ito, ECB versus CBC, na kung saan try nyo i-determine yung weakness pag ECB yung ginamit nyo compared pag sa CBC yung ginamit nyo. Okay? So makikita nyo yan sa lab. Okay? Itong task na to. Okay? May advantage ba ang paggamit ng ECB or may disadvantage ba? But for operation, ito yung nangyayari sa kanya. Okay? Split niya lang siya into kung ano yung size man yun and then independently perform the encryption on each block. Okay? The second one is yung CBC or cipher block chaining, wherein the input to the encryption algorithm is the XOR of the next 64 bits of plain text and the preceding 64 bits of ciphertext. So this is CBC. Okay? So ito yung different blocks niya. These are the different blocks. Plain text, hiwa-hiwalay siya. Pero ang mangyayari dito, unlike sa ECB kanina na independent, no, yung next block independent of the previous block. Ito, yung P2, okay, itong block na to, i-XOR muna dun sa ciphertext na na-produce sa previous block. Okay? And then, saka magpe-perform ng encryption to get the ciphertext. Okay? So you get the idea na kumbaga, may link yung next block from the previous block. Okay? Now, ano yung implication nito? Paano yung first block? Okay? Wala siyang pagkukuhanan ng ciphertext from the previous. Siya yung pinakaunang block, di ba? So, saan siya kukuha nung itong input na to? Dito ngayon pumapasok yung initialization vector or yung IV. Okay? Kasi ito, since this is the first block, user supplied muna ito. Okay? This will be supplied by the user. Kaya meron siyang initialization vector. So that's the purpose of the initialization vector for the first block. Like, kasi wala pa siyang input eh. Okay? The next one is yung CTB. Okay? CFB, cipher feedback mode. The input is processed S bits at a time. Preceding ciphertext is used as input to the encryption algorithm to produce a pseudo-random output which is XORed with the plain text to produce the next unit of ciphertext. So CFB will look like this. Okay. So again, similar to CBC, meron siyang link from the previous block. Okay. And ito yung IV niya. Okay. And then yung S bits, kuha lang siya ng ilang bits dyan, i-encrypt niya yun. and then yung encrypted form na yon, pipili siya ng ilang bits doon, and then i-export sa plain text, and then yun na yung makakuha ka ng ciphertext, S bits, forward mo doon sa next sa next round, sa next block, and then mag-shift lang siya to the left para makuha mo yung S bits na gusto mo. Okay? So yun yung CFB. Okay? Yung OFB is similar to CFB except that the input to the encryption algorithm is the preceding DES output. Wala yung textbook natin, walang output, walang drawing na ganyan. Pero mamaya papakita natin kung paano yung OFB. Pero halos parehas lang naman siya dito. Okay? Sa CFB. And then yung counter naman, basically this is used for high speed requirements. So parang ano siya, parang stream cipher. Each block of plain text is XORed with an encrypted counter. The counter is incremented for each subsequent block. So yan. So meron kang counter, okay, for the first block, and then counter +1, i-increment mo lang siya for the next block, and then encrypt, and then XOR, get ciphertext. Okay, so simple lang yung CTR mode. Okay, so again, para saan tong block cipher modes na to, mode of operation? Kasi dictate niya yung relationship ng isang block sa previous block niya. Okay? May ito yung ECB walang relationship, yung CBC meron, yung CFV meron, yung CTR wala. Okay? So yan. Now the next question is, what if the plain text size is less than the required block size? Oo nga naman, di ba? Di ba halimbawa sa sa AES, ang required block size ay 128, meaning 16 bytes. Paano kung ang gusto kong i-encrypt ay hello lang, which is less than 16 bytes? Anong gagawin niyan? Dito ngayon papasok yung padding. Okay? So para mabuo yung block, ma-complete yung size, maglalagay siya ng additional bytes doon, which is actually called padding. So sa lab, meron din tayong gagawin dyan. So this task here, padding. Okay? So ang gagawin, ano yung ginagamit na standard is yung PKCS standard. Simple lang naman yung rules niya. Padding bytes are always added to the clear text before it is encrypted. Okay? Second, each padding byte has a value equal to the total number of padding bytes that are added. For example, if 6 padding bytes must be added, each of those bytes will have the value 0x06. And the number of padding bytes is at least 1, and it's the number that is required in order to bring the data length up to a multiple of the cipher algorithm block size. So it's best to look at an example na lang. For example, here we have echo betel greater than plain text. Okay? So nag-LS tayo, LS plain text, and makikita natin na yung size ng plain.txt ay 6 bytes. 1, 2, 3, 4, 5. Okay? Bakit 6 bytes? Kasi malamang meron para sa new line character. Okay? Kaya 6. Kung gusto natin ng walang new line character, echo -n. Okay? Yun. And then we encrypt this. Okay? So the usual, and as in the previous example, and we check the size of cipher bin. And what do you notice? What is the size now of cipher bin? 16 bytes, which is what we are expecting kasi we are using AES 128 ECB. Okay, so we have 16 bytes. And then if we decrypt this, okay, and we have the decrypted text, we get the original size, which is obviously 6 bytes. Okay. Now we can also decrypt the cipher and do not remove the padding. Okay. So lalagyan nyo lang siya ng no pad na parameter. And napapansin nyo ngayon na pag nag-ls-l tayo, decrypted no pad, 16 bytes yung lalabas, 128 bits. And then pag nag-XXD tayo, hex dump, okay, we get this value. So malamang ito yung B, ito yung E, ito yung T, ito yung E, ito yung L, ito yung last character. Okay? So recitation, sabi dito, what will be the output if cat is used instead of xxd for the notepad.txt? So dito, instead na xxd, ang ginamit natin ay cat. Ano kaya yung mangyayari? By the way, first, yung 0x 0a, ano ba siya sa decimal? This is what? This is 10, diba? Sa decimal. Okay? So this is the number 10. So bakit sa rule ng padding, great, Kirby, that's great, 10. So sa rule ng padding, di ba sabi kanina, yung value ng pad will be the number of bytes that you're going to use for the padding. Okay? So kaya 0A yan kasi 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bytes yung ginamit natin kasi yung input natin ay 6 bytes lang, di ba? Ilang bytes ang kailangan natin para maging 16 bytes siya? 10 bytes. Kaya 0A, 0A, 0A yung value niya. Okay? So what do you think will happen if pag-cut yung ginamit natin dito? Okay? The correct answer is i-output nyo yung word na Bethel tapos magkakaroon ng 10 additional na new line character. Kasi ito ay treated as a new line character. So meron kang 10 new line character na i-display. Ito ay for this specific example. Okay? So yun. So great. So we now go to the last part, which is the initialization vector. Sabi ko kanina, na-describe ko na kanina yung purpose ng initialization vector, no? So siya yung first input sa first block, okay? Kasi wala pa pagkukuhanan ng input, okay? So another confusion din ito sa mga estudyante, no? Ano ba yung narinig nila lagi itong IV, salt, saka yung nonce, okay? Or NONCE, okay? So i-define natin itong mga terms na to. First, yung nonce muna. Yung nonce is a generic term which means number used once. So isang beses mo lang siyang pwedeng gamitin. Okay? So it's usually used in session management in communication, sa wireless usually. Okay? Or sa exchange of information, mag-exchange sila ng nonce. Okay? So yun yung general term. Okay? Yung IV, this is the initial input to the first block if block cipher mode needs one, as I mentioned earlier. Now, itong salt naman, this is actually used when using passwords. Okay? Di ba, pansin nyo dito, normally sa encryption, no? Normally sa encryption, iisipin mo, akala mo yung key mo ay password, let's say, QWERTY, di ba? Kasi pag mag-i-encrypt ka, hihingan ka ng password. And then, ilalagay mo QWERTY. Okay? Pero eventually, yung QWERTY na yan, i-convert yan into a corresponding key na gagamitin. Okay? So, yung salt, ang purpose niya is that kahit QWERTY pa rin yung gamitin mo na password, iba na yung key na ma-generate niya. Okay? Nakuha niyo ba yun? Okay. So parang marami kang accounts, QWERTY pa rin yung ginagamit ng password. Okay? Pagdating sa database, pag may salt siya, iba pa rin yung lalabas sa kanya. Okay? So yun yung ibig sabihin ng salt. So at this point, dapat ma-differentiate yun na yung IV, salt, saka yung nonce. Okay? So yun. So the last part is yung mistakes in IV. Ano ba yung mga mistakes in IV? Okay? So there are 3 mistakes. The first one is failure to make a unique IV K pair. Okay, key pair, IV and key pair. Ibig sabihin, you use the same IV and key for each plain text. Okay? Dun sa lab, merong task, ito pala yung, ito, ang ginagawa naman itong task na to is to check whether alin dun sa mga modes ang nakakapag-propagate ng error. Ibig sabihin, kaya nyo pa rin makarecover ng kahit konting information, kahit kinurap nyo yung ciphertext. Okay? So ito yun sa error propagation. So dito sa sa IV common mistakes na task, ito yung isa sa mga problem, yung violation, okay, ng uniqueness. So dito pinapa-experiment lang kayo. You'll try to observe ano yung mangyayari if you use the same IV key pair for different plain text. Okay? So yan. Same plain text pala. Okay? So yan. Same plain text and using the same IV or different IV. So yan. It's an experiment. The next one is using the same IV. So ito yung this is another lab. Okay? So itong lab na to, okay? So maraming hindi nakakagawa ng lab na to. Nung task na to, okay? So this is task 6.2. This is the known plain text attack. So let's review ano ba yung known plain text attack. Ang known plain text attack, sabi dito, you know the encryption algorithm, the ciphertext to be decoded, and one or more plain text ciphertext pairs form with a secret key. So looking back at this is basically a known plain text attack. Meron kang, ito yung ciphertext na gusto mong i-decode or i-decrypt. I-decrypt na lang ang correct term is to decrypt. And then, meron kang plain text and meron kang ciphertext. Kaya this is a known plain text attack. Okay? Ang assumption dito is that the mode used is OFB. Okay? Output feedback. Now, kanina, wala akong drawing na pinakita, pero dito, kinuha ko sa Wikipedia. So this is the OFB mode, the diagram for the OFB mode. Take note na walang padding, although may task na ganito, ito giveaway na to, yung OFB, hindi kailangan ng padding. Okay? So, giveaway na to. This can be, i-demonstrate nyo na lang dun sa ibang task kung paano nyo ipapakita na walang padding yung OFB. Okay? So, yung idea nitong itong OFB, mapapansin nyo, kaya siya problematic yung IV reuse kasi kung titingnan nyo itong diagram na to, ang ini-encrypt mo ay yung initialization vector. Okay? So, IV, i-encrypt mo siya, meron siyang makukuha dito na ito yung output niya. Okay? And yung output, after ma-encrypt yung IV, i-XOR mo lang siya sa plain text para makuha mo yung ciphertext. Diba? So, sa scenario natin, meron tayong plain text, tapos meron tayong ciphertext. Diba? So, plain text, ciphertext. Sa input natin, ano yon? Ito yung ating plain text and ito yung ating ciphertext. Okay? So, ibig sabihin, sa attack na to, pwede natin makuha itong part na to. Okay? Kasi in-XOR lang naman siya eh. So, let's denote this as J na lang. Okay? So, we can actually derive J as plain text XOR ciphertext. G. When given na plain text tapos yung given na ciphertext. Okay? And pag nakuha na natin tong J, we can actually use this to decrypt. Okay? Kasi given this relationship, given tayo ng ciphertext, yung ciphertext natin, and nakuha na natin si J. Okay? Kasi halimbawa, same IV yung ginamit. Ito, sa exercise na to, pinapakita dito na same IV yung ginamit. Ha? Given dito na same IV yung ginamit. So, pag nakuha na natin si J, kung gusto natin makuha yung plain text target, anong kailangan natin gawin? Nakuha na natin si J, i-XOR lang natin siya sa saan? Sa ciphertext target. Okay? So, that's the key dito sa ating pag-decode nitong OFB message na to. Okay? Nakuha niyo ba? Nakuha niyo ba yung idea? Ang given sa atin, meron tayong plain text, meron tayong ciphertext. Yun yung given. Okay? And then meron tayong target na plain text. And we are given siguro yan. So ito yung target given tayo, ito yung target natin na ciphertext. Okay? So ang kailangan natin makuha is yung J para makuha natin yung plain text. Okay, malinaw ba 'yon? So baka mahirapan kayo sa Python, so merong binigay na code diyan, okay? Kasi XOR yung gagamitin nyo, okay? XOR operation. So merong binigay na code doon, so you can just examine this, okay? But this is essentially the formula, okay? Another thing na kailangan yung i-consider or i-take note of is yung plain text, okay? Pag sinasolve nyo na to, yung plain text natin ay given as a string, okay? Given siya as a string, okay? So kailangan i-convert siya into hex arrays before mag-perform ng XOR. Take note of that kasi marami namamali na estudyante dito. So ito, kailangan nyo muna itong i-convert into hex array. Okay? So, mapapansin nyo yan dito, itong example na to, a message. Okay? Diyan nyo ipapasok, bigyan ko na kayo ng hint. Ito, ilalagay nyo yan dito. Okay? So, pag nalagay nyo na yan dyan, yung code nyo, itong part na to will convert that to a byte array. Okay? Tapos yung byte array na yon, so halimbawa ito yung ito, pag given ka ng key, so yung hex 1 halimbawa, or halimbawa itong hex 1 na to, no? Ang gagawin nyo lang dyan, itong hex, ito yung hex 1, no? Siya yung ilalagay nyo dito. Okay? So yan. So basically, halos ganoon din yung gagawin niya. Nakuha niyo ba yung solution? Okay? So kung magsusulat tayo, this will be the plain text kanina, PT given, and ito yung ciphertext given. Okay? Will be the given ciphertext. And then pag nakuha, ito naman yung sa ito naman yung sa pwede mong gamitin na target ciphertext. Okay? So yun yung sistema. Okay? Yung way para ma-solve yan. Kaya siya nag-exist kasi ang nangyayari is same initialization vector, same key, and then you get the same J. Okay? Which results to which allows you to easily perform XOR operation. So, yan, you get the PT. Now, using this operation, no, kailangan, ito ay hex ang lalabas dyan. Kasi ang mangyayari, ito yung plain text. Okay? This plain text should be converted to hex first. Okay? So, ito, hex to. Hex yung output na to. Okay? So you need to convert that to, you need to use the code, okay? You need to use the code to be able to get the string, the corresponding string. Okay, malinaw ba yun? So ang sagot dapat dito ay isang string. Okay? Kasi gagamit kayo ng decode, i-decode nyo tong plain text target na to. Okay? So yun. And then the last one is yung another issues with mistakes with IVs is yung use of predictable IVs. So ito yung medyo wala na nakasagot halos kasi hindi nila alam yung gagawin, no? So this is an example of called a chosen plain text attack. Okay? Ito ay known plain text attack, ito ay chosen plain text attack. Ano yung scenario dito? So dito ang block cipher mode na ginagamit ay CBC. So kinopya ko lang yung figure kanina. So ang attack na to, okay, known plain text attack is that you are given a limited set of plain text. Okay? Meron kang pagpipilian ng mga plain text. Parang huhulaan mo. Okay? Yes ba or no ba? Sino ba ang binoto niya? Si BBM ba o si Lenny? Okay? So, parang halimbawa, gusto mong i-crack yung yung boto ng isang botante. Encrypted yung vote, syempre. Okay? Pero gusto mong malaman kung sino talaga yung binoto niya. Okay? So you can use this chosen plain text attack kung predictable yung initialization vector na ginamit niya. Okay? So again, this is AES CBC. Okay? And take note na yung CBC, ito giveaway na rin to, needs padding. So unlike in OFB kanina, na walang kailangan ng padding, diretsong XOR na. Okay? Dito sa task 6.2, after mong ma-convert sa hex byte array itong plain text, diretsong XOR na. Okay? Plain text as is. Pero dito, may padding. Okay? So sa lab nyo, ang gagawin nyo dito ay yes or no lang. Okay? So you have yes or no. Okay? Okay? So kailangan niyong i-pad yan para bago niyo magamit bago mo siya magamit sa program. So gagawa rin kayo ng program actually dito sa sa task 6.3 na to. Okay? So to illustrate the setup, so once na download yun na yung files, okay? DC app lang. So kailangan yung i-start muna yung container na parang magse-serve as Oracle. Okay? So once na nag-start na siya, okay? Anong port ba siya nagli-listen? 3,000, no? So NC 10.9.0.80 3,000. So, ito yung lalabas sa'yo. Okay? So, paglabas ng ganyan, ito yung ciphertext. Okay? Take note na yung ciphertext na to ay, yung plain text niya ay either yes or no lang. Okay? And then, ito yung IV na ginamit niya para makuha itong ciphertext na to. Okay? So hindi mo alam yung key, ang given ka yung ciphertext, alam mo yung yung IV na ginamit doon, and alam mo rin na yes or no lang yung plain text. Okay? So ang goal mo is hulaan itong ciphertext na to, na generate ba to from a yes or from a no. So yun yung gagawin nyo. So how do we solve that? Okay? So we need to understand the knowledge, the mechanism or the structure of CBC. Okay? So, mapapansin nyo dito na yung plain text, okay, in-XOR siya sa IV. Okay? Mapapansin nyo siya na yung plain text nito, in-XOR siya sa IV. And then, after yung na-XOR na yon, i-encrypt yon, and then you get the ciphertext, right? Okay. So the question is, anong information ang pwede mong magamit kung anong attack ang pwede mong magamit kung alam mo yung next IV na gagamitin. Okay? Next IV na gagamitin. Okay? So, ito ngayon yung pinaka equation for that. Okay? So, ang pwede mong gawin kung CBC yung ginamit niya, yung plain text, okay, is equal to guess plus IV, okay? Yung IV0 dito, ito yung IV0, okay? First IV. And i-XOR mo siya sa next IV na nakuha mo or na-predict mo. Dito sa lab na to, binigay sa'yo. In some scenarios, kailangang hulaan mo yung next IV. Okay? So once na nahulaan mo na yan, once na alam mo na yung IV next, i-perform mo lang to, and then this will be your plain text. So, ibig sabihin, sa next round na ipapadala mo sa algorithm, yung plain text dito will be this value. Okay? Such that itong plain text na to, okay, pag pinasa mo dito, tapos yung IV niya, siyempre IV next na yung gagamitin niya, no? So, yung PT na ito, i-XOR siya sa IV next. Okay? Now, pag ganun yung nangyari, maka-cancel out itong IV next na ginamit mo para sa next plain text with the IV next dun sa algorithm mismo. Okay? So, ang maiiwan sa yung term ay ito na lang. Okay? So, kung tama yung guess mo, dapat pareho siya nung ciphertext ni Bob. May portion dun sa ciphertext na pareho nung portion nung ciphertext ni Bob. Okay? Sundan niyo ba yung idea? Siguro mas maganda pag i-illustrate na lang na. Kasi maraming hindi nakakakuha nito, no? So ito yung scenario, no? This is a sample run. Okay? Ito yung ciphertext ni Bob. Okay? And then ito yung IV na ginamit para dun sa ciphertext ni Bob. Okay? So ito yung next IV na gagamitin. So makikita niyo yan dito. Ito yung goal natin. Ang goal natin is to mag-provide tayo ng plain text dito. Ano yung plain text na ilalagay natin dyan. Okay? So, dito sa illustration ko, using this technique, okay? Using this technique, okay? Itong plain text na to, itong plain text na to, yan yung isasalpa ko dito. Okay? Dito sa, ito yon actually. Okay? Now, pag sinalpa ko yan dyan, and then I submitted that, ito yung lalabas na ciphertext. Okay? And then, bibigyan uli ako ng next IV. Okay? So, mapapansin nyo na itong part na to ay magkaiba dito. Okay? So, nalimutan ko na kung yes or no yung kung ginamit ko dito, but notice na magkaiba siya. Di ba? So, ibig sabihin, sa next round, pwede uli akong mag-compute ng next plain text using this formula uli. Okay? So, pag click ko ng submit, ito yung tumambad sa akin. Okay. So, ibig sabihin, ito, observe na ito, saka ito, ay pareho. Di ba? May similarity. So, ibig sabihin, tama na yung hula ko. Right? Tama na yung hula kasi yung ciphertext ko dito ay pareho ng ciphertext ni Bob. Okay, sabihin, nag-guess ko ngayon yung ciphertext ni Bob. Okay? Malinaw ba yun? So stop na ako doon kasi dalawa lang naman yung pagpipilian ko yes or no. So ang una kong attempt, mali. Yung pangalawa kong attempt, tama na. Okay? So yun yung ibig sabihin nitong part na to. Now, ang challenge dito is paano nyo kukomputin to? Okay? So IV0, given na yan. Okay? So yung IV0 sa formula na to, yung IV0 is actually this one. Okay? This is IV0. Okay? The next input will be IV next. So yung IV next, ito na yan. Okay? So ang goal natin ngayon is ang isang mga challenge is yung guess, ano yung guess, di ba? Ano yung value na guess na gagamitin natin. So, meron ako ditong code fragment, okay? So, this is important, no? Para ma-solve nyo yung exercise na to. Okay? Ito yung guess na gagamitin mo. Okay? Di ba sa term na to, kailangan mo nung guess. Okay? So, again, kailangan i-convert mo sa hex yan. Okay? So, ito yung first, ito yung part na pag-encode pag-convert ng yes string into hexadecimal byte array. So mapansin mo, this is a byte array, yes, okay? And then you concatenate that with this one. Para saan nga to? Ito ay para sa padding.
Padding.
Okay, great, good. Para sa padding yan. Kasi yung yes, tatlo, 16 minus 3, that will be 13. And 0D is for 13. Diba? Correct. Tapos multiplied, repeat 13 times. So that will be the padding. So the same with this one. So once you have the padding, okay, makukuha mo na yung kanyang, ito na yung term na guess na gagamitin mo. Okay? So, alam mo na yung guess, alam mo na yung IV0, alam mo na yung IV next, then you're going to use this PT. You will be able to compute that, and yung PT na yan yung ilalagay mo dito. Pero make sure na hex din yan. Okay? Hindi siya string lang, hex din dapat siya. Okay? So, as shown here. So, ibig sabihin, itong value na to, okay, take note, itong value na to, okay, na-generate ko siya using this, ito siya bale, okay? Marami nagkakamali dyan, okay? So ito siya, itong PT na to, na na-compute ko using this input, siya yung ilalagay ko dito, sa area na to. Okay? Malinaw ba yun? So, that's it. Basically, yung ating lab exercise. Yung topic for today. Medyo nahihirapan lang talaga yung mga estudyante dito sa task 6.2 saka 6.3. Una kasi hindi nila ma-derive tong equations na to. Pero once na-derive na kasi yung equations na to, straightforward na lang yan. XOR naman eh. And you have code on how to perform XOR and sample code. Okay? Malinaw ba yan? So yan, guys, yung ating topic for today. So thank you all for coming. So I hope you will be able to solve this task. Maraming hindi nakaka-solve nito eh. Okay, so thank you very much. See you next meeting.
Thank you po, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you po.
Stop.